Hello everyone, my name is Samirah Khairunnisa. I'm from ICT 03, and for Mathematics in Economy and Business, I'm going to discuss about application of derivative in business, which is optimization with one variable. Okay. If the function has only one independent variable, the rules to find out the optimization will be: first, it is to define the first derivative. Why? It is because to find the extreme or the stationary points. The formula for it will be b of x divide dx, which means equal to 0. The second rule, it is to fill in the stationary points to the second derivative of fx. There will be three conditions in it. The first condition will be if d square of x divided dx square is bigger than 0, that means the stationary points will be minimum. For the second condition, if d square of x divided dx square is less than 0, that means the stationary points will be maximum points. The third condition, if d square of x divided dx square equals to 0, that means the stationary points will be the saddle points. What is the saddle points meant? It is, for example, you found a question, and when you already applied to the second rule, you found out that the answer equals, or the stationary points, it equals to 0. It can't be calculated manually, and therefore you have to use or utilize a computer to find the answer. For the next step, we are going to form the curve from the original function. For example, here the function it is ax over 4 plus bx over 3 plus cx squared plus dx and e. For the curve, it is usually flow in from this, as you can see. It is starting from B, then you go to the C, and then go to the A. It usually flow in this curve. Okay, I'm going to explain one of the example. Okay, in this example, the function will be y equals to x over 3 minus 3x squared minus 9x. In this question, we will going to find the form of the curve. The first rule it is to define the stationary points by searching the first derivative. The first derivative of this function, it is 3x squared minus 6x minus 9. After already searching for the first derivative, we are going to find the stationary points. What is the formula? It is df divide dx equals to 0. 3x squared minus 6x minus 9 equals to 0. So, to make it easier for us, we are going to divide it into 3. That leads us to x squared minus 2x minus 3 equals to 0. Then from this function, we are going to factorize it. The answer will be 6 minus 3 and 6 plus 1, and x plus 1. Then from here, we will get 6 minus 3 equals to 0. That means x 3. And for this one, it is x plus 1 equals to 0, which will be x means minus 1. So from before, we already found the first x and the second x, which is for the x1 equals to 3, and the second x it is minus 1. Now we are going to substitute the x as t to the function y, which is x over 3 minus 3x squared minus 9x. Okay, so we're going to use the first x, which is 3, then y1 will be, we are going to put this value into this function, which is 3 over 3 minus 3 times 3 squared minus 9 times 3. It equals to minus 27. Next, we are going to use the second x, which is minus 1 into the second y. Y, which is minus 1 over 3 minus 3 times 1 square minus 9 times minus 1. It will be equal to 5. Okay, now we already found the first and the second x and also the first and the second y. That means the stationary points are gonna be 3 minus 27 and minus 1 and 5. Now we already found the stationary points. Next one, we are going to apply the second rule, which is to define the max or minimum or the saddle points. Okay. Now we are going to find the second derivative of y. Okay. The second derivative of this function, it is 6x minus 6. From this, we are going to substitute the x1 and the x2. Okay, from the first x, which is 3, y dx squared, which is 6 times 3 minus 6 means it is 12. So from the condition, we can conclude that it is bigger than 0. That means it is going to be minimum points. Okay, now we are going to apply the second x, which equals to minus 1. Now we are going to substitute it. D square y divided dx square equals 6 times minus 1 minus 6. It equals to minus 12, which means it is less than 0, and we can conclude from this it is to be maximum points. So this one, it is to prove that this stationary points, 3 point minus 27 to be minimum point, and for this stationary point, which is minus 1.5 to be maximum points. So now we are going to the last step, which is to draw the curve. So from before, we can get the result, which is 3 point minus 27 to be minimum point, and the second stationary point, it is minus 1.5 to be the maximum point. Now we are going to draw the curve. here is the curve, and now we are going to apply the stationary points to the curve. Okay, first it is 3. We are going to point here minus 27, which means the point will be here. For the second stationary points, minus 1.5 from here, and now we are going to here. This will be the second stationary points. To draw the curve, it is to be like this. It has to go through the 0, 1. Don't forget this. We are going to connect it. Voila! This is the curve from our question. Y equals to x over 3 minus 3x squared minus 9x to be this curve. Okay. And then it is all of my explanation about optimization with one variable. I'm sorry if there is a mistake or misunderstanding in my explanation, and I'll see you guys around. Bye-bye!
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Dayyan Taqiya and I am from ICT Class 3 Group 1, and I will be teaching you guys about the partial differentiation and optimization with constraint using the Lagrange method. So what is the Lagrange method? It is a calculation of the extreme value of a function that faces a constraint in the form of another function. So the Lagrange function consists of two functions, which is z equals to f x y, which is the function that needs to be optimized. And for the conditional method, for the conditional constraint method, it's u equals gxy. So by combining these two functions, you make the Lagrange function, which is capital F xy lambda equals to f bracket xy plus lambda times g brackets xy. So now we'll go through the steps to determine for optimization functions with constraint. So the first step is to determine the first partial derivative and it should be equal to 0. So we'll get three variables, three equations, which are df over dx equals to 0, df over dy, and lastly df over d lambda. So when we get three equations, three variables, we'll also get three equations that we're going to use to eliminate and substitute with each other. So then we'll have the second step, which is to determine whether the utility function or maximum objective function falls under two conditions. Firstly is to find the second direct partial derivative and the cross partial derivative. And the equations for the four equations for the direct partial derivative and the cross partial derivative is d square f dx squared, delta square f delta y squared, then d delta square f delta x delta y. This is also important because the conditions that the first condition is connected to the second condition, which is forming the Hessian determinant. So by forming the Hessian determinant, we'll be using the direct partial derivative and the cross partial derivative with fxx, fyy, fyx, fxy, and also gx and gy. And this comes by from this subjects from the constraint equation, which is gxy. So at first we'll put in the matrix diagram and it will look like this. So the matrix diagram will look like this. So if you convert it into a function, into an equation, it will be g2gx times gy times 5xy bracket minus gy squared fxx minus gx squared times fy. So from this, we'll get two answers, which is if the Hessian is bigger than 0, the function of z has maximum relative. But if the Hessian is lower than 0, the function of z has minimum relative. So let's move into an example question. So the question is, determine the extreme value z equals to xy, provide x plus 2y equals 10. So let's see what are the given equations. First, we have z equals to xy and x plus 2y equals to 10. So we know that the main function is z equals to xy, since the optimized function is z equals to f xy, and this we know is a constraint function, a constraint equation, because the condition that they should be met is u equals g xy. So let's write it down. Equals to xy, and the constraint is x plus 2y equals to 10. So again, in the Lagrange method, you have to combine both the main function and the constraint functions together. So the Lagrange function looks like this: x, y, lambda equals f, x, y plus lambda, g, x, y. Here you go. So now we want to make the new function as subject to the constraint without changing the xy itself. So first we have to move the x plus 2y to the other side, and it'll look like xy plus lambda 10 minus x plus 2y, and then we open the brackets, which will become xy plus lambda 10 minus lambda x minus lambda to y. So after this, we're gonna apply the rule of making df over dx equals to 0. At first we have to derive it from here, so we'll get y equals to lambda, then equals 0. We'll move the lambda to the other side to make it positive. So it will be y equals to lambda. Then we'll have lambda f over lambda y, which is x minus 2 lambda. And again, we do the same thing with this one. With this one, we equal it to 0, and we'll get x. We move the 2 lambda to the other side to make it positive 2, so we get 2 lambda. So now we have two equations. So this is where the substitution comes, where we substitute 1, 2, to 2, so we'll get x equals 2 lambda, and we'll substitute the y, which will become 2y. So this is our third equation. Since we already did delta x and delta y, we'll move to delta lambda. So again, it's 0 plus 10 minus x minus 2y, and then we'll equal it to 0, which will become 10 minus x minus 2y equals to 0, and then we'll move the minus x and minus 2y to the other side to make it positive. So you get 10 equals to x plus 2y equals to 10. And this is your fourth equation. So then we'll substitute 3 to 4. So the equation 3 was x equals 2y, and 4 was x plus 2y equals to 10. So then we'll substitute x to 4, as I said. So it will become 2y plus 2y equals to 10. So it's 4y equals to 10. So it's 10 divided by 4, or we could say 2.5. So next we substitute the y back to equation 3. So it's x equals 2, 2.5, and you get 5. So now lastly we have to find the lambda, and we have to do by taking the fifth equation, since in the first equation it's x equals x, y equals to lambda. So we can substitute the y to the first equation, so we'll get 5 equals to lambda. 2.5, sorry, 2.5 is lambda. So now you got your stationary points. So as we said, x is equals to 5, the lambda is 2.5, and the y is also 2.5. So we'll now determine the minimum and maximum value, and first we have to find the second derivative. So we have delta square f over delta x square. It will become 0. Then delta square f over delta y square will also be 0. Then delta square f over delta x delta y will become 1. So the next one will have delta g over delta x, and this is from the constraint equation. So we'll get 1 here, and delta g over delta y becomes 2. So now we'll take these variables and then move them into the Hessian diagram. So we'll get 2 times 1 times 2 times 1 minus 2 squared times 0 minus 1 squared times 0. So when we calculate all this together, we will get 4. And since 4 is bigger than 0, the function has a maximum relative than z. So that's all I have for the partial differentiation. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muammar Fadhel Fellafi. I'm from Group 1 of ICT 3. So the topic that we'll discuss today will be derivative partial or partial derivative. So the first derivative partial will be the basic function will be y equal to f x1 or x2 or whatever variable that you use. And for the example that we'll discuss is y equal to f x y. The function will be 5x power 2 plus 4x xy plus 3y squared. So we're going to bring it down to searching for the y and the x. We're going searching for the x1. So this is that we'll use. Since there's no x here, we're not going to bring it down. So it's 2 times what? 2 times 5, it will be 10x, and plus, since we're searching for x, cross x, it will be 4y, and the second f, it's the y per the y equal to, since we're looking for y, this is the equation that we'll use. Cross y equal to 4x plus 2 times 3, it's 6y. So this is for the first derivative partial. The second that we'll discuss is derivative partial, the second. The difference between the first one and the second one is the second one, we're going to bring it down 2 times, unlike the first one, which only once. So the example that we'll use is z equal to x power 3 minus 9xy minus 3y power 3. So like the first one, we're going to do it just like it. X, we're going searching for the x1. So it's 3, bring it down, it's 3 times 1, it's 3x minus 1, it's power 2, and it's minus, so we're searching for x slash 9y. And fy we're searching is, just cross the y, will be 9x minus 3 times 3 is 9, y power of 2. So this is just the first one. So we're going to do the second one. So fx, let's just say we want fxx. We're going to search for the x again. It's 2 times 3, it's 6. X, 2 minus 1, it's 1. We don't need to write that. And for this, it's fyy, for example. There's only one y. We're going to bring it down. 2 times minus 9, it's minus 18. Y. 2 minus 1, it's 1. We don't need to write it again. We can search for like this, for example, fxy. Search for the y1. After we search for the x1, it's going to be, since it's 1 minus 9, it's minus 9. And since it's going to be minus 1 again, it's going to be 0. Y to the power of 0 is 1, and we don't need to write y again. And for fyx, we're searching for x after we search for y. It's 1 times 9, it's 9, minus 1, it's 0, we don't need to write x, so here it is for the derivative partial, the second. But the next one that we'll discuss is the difference between derivative and differential difference. So for derivative, since it's dy per dx equal to f dx, the only difference is we're going to add the x at the end of the function. For example, let's just say 3x squared plus 5x minus 4. We're going to bring it down. 2 times 3, it's 6. 6x plus 1 times 5, it's 5. And minus 0. It will be 6x plus 5. That's for derivative, but for differential, we're going to time it with dx. That's the only difference between derivative and differential. So the last one that we're going to discuss is differential total. So differential total will be very simple. We're only going to search for 3 points of answer. The example that we use is z equal to 5x power of 3 minus 12xy and minus 6y power of 5. So the first point, we're just going to search for zx and searching for zy. For zx, bring it down, 3 times 5, 15x power of 2 minus 12y. That's it for the zx. For the zy, slash y minus 12x minus 5 times minus 6 minus 30y power of 4. That's for the first point. The second one will be the same as this, but we're just going to add dx at the end, like this. X power 2 minus 12y x and zy will be minus 12x minus 30y power of 4 will be dy. Don't forget, we should follow this one, x. For the third one, we're just going to add it dz, zx plus zy. This is 15x squared minus 12y x plus minus 12x minus 30y over 4 dy. That's it. Thank you. Thank you for listening. Sorry if there's any mistake or any misunderstanding in my explanation. I hope we can learn better from this explanation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Ikbar Nafisa and I'm from ICT 3 and I'm gonna explain about matrix. But first, what is matrix exactly? Matrix is a set of numbers that organize into row and column. First, let's talk about the order of the matrix. For example, we have A, 3, 2, 1, 4, minus 2, and then 7. What exactly is this order of the matrix? Since this matrix has a two row, so we put it here, and 3 column, 1, 2, 3. So basically, row means horizontal line and column mean vertical. So for this matrix, we call it 2 times 3 matrix. And then next one, how do we specify for each of the element of the matrix? For example, we want to have the A, 3, 1. A, 2, 2. What is the element of the matrix? So we can go to the second row here and then go to the second column. So it was minus 2. And how about the 1? A1, 2. So basically it was the first row and then the second column. So it was 2. Okay. Next, let's move on to the basic operation of the matrix. The first one will be transpose. So basically transpose, we change the shape of the matrix by flipping it. For example, we have A 7, 2, 4, and 3, 2, 1. So the way this works is the first element. The first element stays the same. For example, 7. 7 we put it here because it was in the first column and the first row. We put it here, and then the next one is the second column and the first row. We put it in the first column and the second row, so it will be 2. And then the next one is the number 4. We put it down here. And then same goes with the rest of the number 3 to 1. So at first it was 2 times 3 matrix, and then it changed to 3 times 2. Okay, for the next one is second operation is addition and subtraction. So for example, we have A 3, 2, and then 1, and then 5, and then for the B is 4, 1, 2, 1. So as you can see in this matrix, it's the same order, 2 times 2 by 2 times 2. So the next step is to A plus B. As you can see here is that 3. Just add 3 with 4. 3 plus 4, and then 2 plus 1. 2 plus 1, and then 1 plus 2. 1 plus 2, and then 5 plus 1. So the final matrix is 7, and then 3, and then 3, and then 6. Same goes to the subtraction. All you have to do is just minus the matrix A and minus it by matrix B. And then next, let's move on to the multiplication. For the multiplication, here we have the rule for it. So the rule is, if we have the matrix 2 times 3, for example, A 3, 2, 4, 1, 7, 2. We need to 2 times 3 matrix. We have to match that with 3. We have to match that with matrix 3 times as much as you want. For example, here I'm gonna go with 3 times 2. So for example, for the B1 is 4, 1, 3, 2, 1, 2. So all I have to do is just times the first row with the first column here, times it here. So it will be 3 times 4 plus 4 times 1, and then plus 7 times 3. And then goes on with the second row times with the first column. So we have 2 times 4 plus 1 times 1, and then plus 2 times 3. And then let's move on to the next column here. So the first row times the second column. 3 times 2 plus 4 times 1, 7 times 2. And then the next one, the second row times the the second column. 2 times 2 plus 1 times 1 plus 2 times 2. So for the matrix A, multiplication by B is 3 times 4 means 12. 12 plus 4 plus 21, and then the second one is 8 plus 1 plus 6, and then 6 plus 4 plus 14, and then 4 plus 1 plus 4, and then so the final answer is 2 times 2. So you get the final matrix looking at the first row and then the second column. So it will be 2 times 2. So the final answer is 37, 24, 15, and 9.
Okay, for the next operation, we have the determinant. For example, we have here A in the matrix 2 times 2. We have A, B, C, D. So the determinant will be the first column and the first row times the second column and the second row. So it will be like A, D minus with B times C. B times C. So it will be like A, D minus B, C. Okay, so next move on to the real number. For example, we have here B in the matrix, same 2 times 2. We have 2, 1, 4, and then 3. So it will be the same like this one. The first row and the column times the second row and the second column. So it will be like 2 times 3 minus 4 times 1. So we have 6 minus 4. So the determinant for the B is 2. Okay, next we move on to the inverse. For example, we have here A in the matrix we have same A, B, C, D. So for the matrix it will be like 1 per determinant of the matrix A times the matrix. So we have like in the determinant 1 we have A, D minus B, C. Like this. So the final one is just A per ADBC, and then the next one is B per ADBC, and then for the C, AD minus BC, and then for the last one is DAD minus BC. Okay, next let's try to move on to the next. We move on to the real number. For example, we have matrix B. The matrix is the simple one, 2, 1, 3, and then 2. And then at first we need to find the same, like the determinant of the B. Like usual, we need to times 2 with 2, so it will be like 4, and then minus it with the second column in the first row, so it will be like 3 times 1 means 4 minus 3, and then here we put the 2, 1, 3, 2. So we have 1 per 1, and then the matrix 2, 1, 3, 2. So it will be like the scalar matrix. So the final matrix will be 2, 1, 3, 2.
3.
Okay, I think that's all for the matrix material. Thank you. Goodbye. Assalamualaikum warahmatullahi wabarakatuh. Okay, hello everyone. My name is Ikbar Nafisa, and I'm gonna explain to you guys about math finance, about exponential. So exponential function in math finance are used to describe how things grow and shrink rapidly over time. Imagine you have an investment that grows at a certain rate of the year. The amount of the money you have after several years can be represented as an exponential function. And here we have the example. Dayyan has 5,000 and she is going to invest in a bank that grows at a rate of 8% per year. How much is it after 3 years? Question mark. Okay, so here is the equation about the math finance. So A is represent the future value and P is the initial principal. So here we can put the 5,000 in the P, 5,000, and then we can put 1, and then the R here is the growth rate, which is the 8% per year, so we put 8, and then the T means the times after the several years, because we need to find how much is it after 3 years. We can put 3 in here. So we need to make this decimal number. So we can write it again, 5,000 times 1 plus 0.08 power 3. And then, so after we calculate this, we can put it in here. So it will be 6,664.32. Oh, sorry, I need to put the dollar. Okay, that's how you do the math finance about exponential. I think that's all for me about math finance. Okay, thank you. Ciao.